Hi, hello everyone. Welcome to Vision classes. It's a classes for IGCSE, GCSE and IB student around the globe. So today we have to discuss IGCSE Physics syllabus and the difference between core syllabus and extended syllabus. So students who are going to choose the core, they have a less topics compared to extended student. We are going to discuss the even syllabus for exam 2023, 24 and 25 straight away. Before we move ahead to the syllabus topic, my name is Dhanraj sir and I teach maths and physics to IGCSE and GCSE student. We have nearly student around more than 10 countries, and if you want to connect with us for classes for regular batches, I have left the contact in the description box. You can straight away connect with us. We have started already batches for 2024 and 2025, because if you start early, then probably you will get the good grade and it will help you to build a strong base for physics. What's the importance of taking physics as a IGCSE subject? So in IGCSE, nearly 70 subjects are there. So physics is one of the interesting subject, including maths and chemistry, biology and other subjects. So why physics? Because generally around us we have a tab, then mobile phone, iPhone, the iMessages, then radios. Suppose air is moving, why the air is moving, how it moves, and all those physics phenomena are discussed in physics actually. Then you can learn the scientific fact and even apply those scientific facts in a real life. It will help you to explain any concept very easily if you know the physics very well, physics theories very well. Then what's the IGCSE physics structure? They have categorized as a core paper and extended paper. Paper 1 and paper 3 are core paper. Paper 2 and paper 4 are generally extended paper. And for core student, they will get the grade from C to G, and for extended student they will get the A star to G grade. For the core student, expected to perform D or below, and the extended student at least C and above, means A star or maximum. This is how IGCSE physics structure they have developed. Fine. Frankly speaking, the core paper are for those who feel physics little bit tough and they have a very simple concept, straightforward questions. For extended student, they have to apply their own knowledge as well while tackling the questions. And for extended student, more challenging questions they will get in the exam. So here comes the role of our classes, how our teachers, how our tutors actually help you to get A star grade. Here our teachers actually communicate effectively, clearly using scientific technologies, notation, convention. We have learned certain things relating to the IGCSE, so that those concepts we explain the student very well, and that will help you student to build your strong background. Fine. Then nextly, our teachers actually explain the any scientific knowledge in a such a way that it will help you to get even good grades as well, because last few years all our students got either A or A star. We will make you sure that you will get the good grade and student can enjoy the science and develop the informed scientific mindset. For IGCSE physics, 6 topics, then thermal physics, waves, electricity, magnetism, nuclear physics and space physics. These topics again subdivided into some topics. We will discuss it here. Look at this one, paper 1 to 6. So paper 1 is for core student and paper 3 for the core student. Paper 1 is of multiple choice question and paper 3 of short answered structured question, right? And here then nextly, for an extended student, paper 2 of multiple choice question of 40 marks. Fine. And paper 4 short answered structured question paper will be there and it is of 80 marks. Fine. Paper 5 practical test and paper 6 is for alternative to the practical. Fine. And these are just you can choose either 5 or 6 as per your convenience. This one here, left hand side, is for core student and right hand side for extended student, right? So for extended student, they have a core plus supplement syllabus is there. In a motion and forces, first topic we have physical quantities and measurement techniques. So physical quantities, SI units. For an extended student, the quantities of force, weight, velocity, acceleration, movement, electricity, strength, gravitational field strength. Next topic, speed, distance, then velocity, acceleration. These concepts are there for the core student. Apart from this one, extended student, acceleration is nothing but change in velocity over change in time. So constant acceleration, changing acceleration, how to identify graph. You will get the graph based question for an extended student. Fine. Then nextly, extended student, you have to learn the deceleration means what and the concept related to the motion of an object falling in the uniform gravitational field. Then nextly, mass and weight. Third subtopic under first topic is mass and weight. So mass, what's the difference between mass and weight? Then describe the concept. Nextly, density. Density is mass per unit volume. So extended student, you have to learn one liquid, whether one liquid float on another liquid, what's the reason, concept related to the density. Then nextly, fifth subtopic is force, effect of forces. Then for extended student, they have to learn spring constant K is equal to F over X. So limit of proportionality constant. These concepts are important. For core, actually you have to interpret the load and extension graph, then result of two or more forces acting on the same straight line. For core and extended student, they have to learn effect of forces, solid, friction, then the drag force, what's a drag force, what's a air resistance. Then nextly, turning effect of forces, moment of force, the principle of movement. For an extended student, you have to learn the graph based question, how to apply the principle of movement to solve any questions. Seesaw related questions are there for your exam perspective. So then nextly, the center of gravity, then gravity of an irregular shape, then nextly, effect of position of center of gravity. So these concepts are there. Nextly, the momentum concept. Momentum is concept specifically for the extended student, not for the core student. Moment is equal to mass times velocity, energy, work and power. So energy, work, power concepts for a core student, only basic things are there. What are the different types of energies are there? For example, mechanical energy, electric energy, electromagnetic, sound, other wave energies are there. So those types of energy and their units, okay, formulas are there for the core student. Now for extended student, they have questions or numerical questions on the kinetic energy, potential energy, the principle of conservation of energy. These energy you have to apply to solve any type of questions. Okay, here what's a work? Equation of work done is nothing but mechanical energy or electric energy. So these formulas are there. Then nextly is energy resources. We have a different energy resources are there. So for example, chemical energy, water, hydroelectric energies, then geothermal, nuclear, light energy, solar power plants, right, infrared rays. Nextly, there are advantages, disadvantages you have to learn. Then you will get one question on advantages or disadvantage of energy resources. Okay, then for a extended student, apart from these types of energy resources, you have to learn the efficiency concept, how to apply this efficiency concept, how to calculate efficiency. Fine. Here power is equal to work done per unit time, right? So this is power concept, and power concept is basically are there for both extended as well as core student. Then nextly, the pressure is equal to force per unit area, and for extended student they have to just apply the equation of change in the pressure beneath the surface of the liquid. For the liquid, you have to use this change in pressure formula as well for the extended student. Then second topic is thermal physics. Thermal physics, you have a first subtopic is kinetic particle of matter or kinetic theory of a matter. So solid, liquid, gases, how they behave in the different temperature, okay, collision of particles. The basic concepts are there for core student, and for extended student, how they behave, particle affect the properties of solid, liquid, gases, fine, how they behave, then collision of a gases, particle, effect of pressure, temperature, volume, basically for both of them, extended and core student. And here for a extended student, they have to even learn and understand the formulas relating to the gas laws, fine, then numerical questions as well, graphical representation, fine. Then nextly thermal properties and temperature, the second subtopic. Here the thermal expansion of a solid, liquid, gases, you have to understand theory related to it. Then nextly you have a specific heat capacity. So specific heat capacity, C is equal to delta E upon Em times delta T or delta theta. And for an extended student, you have this formula is there, you have a straightforward questions are there, how to calculate the specific heat capacity and all. So you have to understand and you can tackle those questions very easily, fine. Then nextly melting, boiling, evaporation, this concept, their definitions. And for extended student, describe how temperature, surface area, air movement affect the evaporation. Basic concept is there for a core, and the next, how temperature, surface area, air movement affect the evaporation for the extended student. The transfer of thermal energy, third subtopic. So we have a conduction, convection and radiation. So those concepts, for basic concepts for the core student, and for extended student, what happens in the conduction, little bit more in depth you have to study for the exam. Radiation for an extended student, you have to learn distinguishing between good and bad emitter, absorbers. Then the emission of radiation depend upon the surface temperature, surface area. Then nextly consequence of thermal energy transfer, what happens. So in the, let's say for example, kitchen pan, heating room by convection, these things you have to understand for extended student. Types of thermal energy transfer in case of fire burning, radiator in the car. So applicability is important. Then third topic is wave. General properties of waves are there for the core as well as extended student. Wave speed equation is there. Numericals are there for a extended student. For both of the core as well as extended student, they have to learn different types of waves, P waves, S waves, longitudinal waves. You have to learn reflection, refraction, diffraction topics, concepts related to those topics. Then for an extended student, actually they have to learn the even problems relating to the wave speed, how wavelength and gap size affect the diffraction through the gap, then wavelength affect the diffraction, how it affects. So second subtopic is light, reflection of light, normal, angle of incident, angle of reflection. Okay, so for an extended student, construction and reflection by plane mirror you have to learn, and there are few diagrams are there. You must know those diagrams to tackle any kind of questions. Then here you have a basically angle of incident, angle of reflection, right? And the critical angle theory part is there. For extended student, you have a n is equal to sin I upon sin r, their problems. Then n is equal to 1 upon sin c, critical angle, their applicability in the optical fiber, particularly for the telecommunication purpose, fine. Then nextly thin lens, basic concepts such as diverging lens, converging lens, then ray diagrams, characteristics of ray diagrams, then what's a virtual image. These basic concepts are there for core student. And for extended student, draw and use of ray diagram, describe them. Then nextly use of converging, diverging lens. So these concepts are there for extended student. Then nextly dispersion of light, how white light disperse when it passes through the prism. For extended student, single frequency description as a monochromatic light. Okay, this part is there for extended student. In the third subtopic, you have an electromagnetic spectrum. So in an electromagnetic spectrum, you have to understand the electromagnetic spectrum, radio waves, microwaves, satellite television waves, then infrared waves, visible, ultraviolet light, X-rays, gamma rays. Okay, these rays are there for both extended as well as core student. microwave, infrared, ultraviolet rays, gamma rays. Fine. So their harmful effect. For extended student, you have some questions on speed of electromagnetic waves in the vacuum is 3 times 10 raised to 8 meter per second. The electromagnetic spectrum, you have a satellite phone and their applicability. Okay, what's a geostationary satellite and how we can use them. For an extended student, you have a little bit of more in-depth knowledge here, and it's a very interesting actually. Fine. To be frankly speaking, because you will get to know how mobile phone towers work, Bluetooth, how it works, then optical fiber. Right now we are taking online classes, or let's say for example we connect from one country to another country. We are connected with nearly more than 10 countries. How communicate from one country to another country, how optical fiber works, these kind of things you will get to know in the physics. Fine. And that is why the physics makes very interesting actually. Fine. Then nextly, for an extended student, they have a difference between the digital and analog signals, then how they are transmitted. Then next subtopic is sound, how the production of sound takes place. Fine. Definition, what's a human hearing range, what's a ultrasound, what's a speed, then compression, rarefaction. These concepts are for extended student. Nextly, for a core student, what's the amplitude, frequency, wave speed, echo, ultrasound. For a core student, applications of ultrasound in a medical field, calculating depth of water. Then nextly, fourth topic is electricity and magnetism. It's one of the interesting topic, and it's completely again correlated to our surrounding. So for core, both extended student, they have some basic topics such as magnetism, magnetic properties, then difference between the properties of temporary magnet, permanent magnet, difference between magnetic and non-magnetic materials. So bar magnet, the magnetic field lines with the compass, iron filing, then permanent magnet, electromagnet. We have to understand these concepts. Then for an extended student, the magnetic force are due to the interaction between the magnetic field. The strength of magnetic field represented by spacing the magnetic field line. So how magnetic field line closer means the more or stronger the magnetic field line field we have to discuss in this topic. Okay, then nextly we have electric quantities, means electric charge. So how electric charge repel or attract, the electrostatic charges by friction, distinguishing between the electrical conductor, insulator. Okay, for an extended student, you have to learn the formulas, then what's the electric field, their definition, okay, their units. It's a little bit of extra thing. Fine. Then electric current. So for an extended student, I is equal to Q over T formula, then question relating to the formula. Fine. Then nextly, difference between the direct current, alternative current is there. Okay, so these concepts are there for both core as well as extended student. And for an extended student, they have some numerical extra questions on the electricity, and those are straightforward questions, very easy to tackle. Fine. Then nextly, electromotive force and potential difference. So for a core as well as both extended student, you have to understand electromotive force. Then what's a potential difference, you have to define them, you have to understand their units. Okay, for extended student, you have a formula, E is equal to W over Q and V is equal to W over Q, and numerical problems on this one. Then nextly, resistance, V is equal to IR or R is equal to V over I. Ohm's law. For extended student, you have to learn and understand the current voltage graph, how resistance affect. Fine. Then resistance is directly proportional to the length. Okay, so resistance is inversely proportional to the cross-sectional area, resistivity concept. So these concepts are there, their numerical problems are there. Then nextly, electric energy and electrical power. Electrical power, P is equal to VI, and electrical energy is equal to VI T, and we have to define these units, kilowatt hour, we have to calculate even cost of electric appliances where energy unit is kilowatt hour, and these concepts are there for both core as well as extended student. See here, circuit diagrams are very important. Means cell, battery, power supply, generator, then resistor, light dependent resistors, LDRs, okay, fuse, relay. Circuit diagrams are important. Okay, for extended student you have to understand what's the function of a diode and LEDs, fine, and how we can use them in the circuit. Okay, then nextly series as well as parallel circuit. Just for core student they have a simple circuits are there, but for extended student they have some calculation part is also there, some of current entering in the junction and things like that, total potential difference across the component in the series circuit. Then parallel circuit, you have to understand what's the potential difference, how it affects, okay, what's the current in the series circuit, in the parallel circuit, what's the potential difference in the parallel circuit, series circuit. These differences are there for extended student. Then nextly, here as I told, here you have to understand the construction of series as well as parallel circuit, EMFs, then combined resistance, parallel circuits, okay, combined resistance of two resistors in parallel, fine. Then advantages of connecting loop in parallel as well as series circuit. Okay, so means advantages, disadvantages we have to discuss, okay, relating to the parallel as well as series circuit. Then nextly, here the potential difference across the electric conductor increases at its resistance increases, fine. So we have to here for an extended student, equation of two resistor and potential divider is here, R1 upon R2 is equal to V1 upon V2, fine. And for both core as well as extended student, electrical safety measures, fine. So next part is electromagnetic effect, and this is very important. So for a core student they have to understand electromagnetic induction. What's electromagnetic induction, and demonstrate the electromagnetic induction, what are the factors affecting the magnitude of EMF, AC generator, they have to understand. And for core student, the direction of induced EMF, fine. Then concept relating to the direction of force, field and induced EMF, some laws are there. Okay, you have to sketch and interpret the EMF, AC generator, so use of slip rings and brushes, you have to understand these concepts. Then magnetic effect of current, the pattern and direction of magnetic field, then identify pattern and magnetic field due to current, quantitative variation of strength of magnetic field around the straight wire and solenoid. These concepts are there for extended student, fine. Then describe the electric effect or effect on the magnetic field around the straight wire and solenoid. So what are the here effect takes place, we have to discuss, fine. Then nextly, current carrying conductor. So for a current carrying conductor we have a current and direction of field, right? And then the use of relative direction of forces, magnetic field and current, direction of force on the beam of charged particle. Then nextly we have a DC motor. DC motor is concept for both core as well as extended student, number of turn, current and strength of magnetic field, how these affect in the turning effect, fine. Then nextly, for an extended student relating to the DC motor, which is operation of electric motor including action of split ring, commutator and brushes, fine. Then nextly, transformer. What's the basic function of transformer? What are the soft iron core? What's the primary, secondary, step up, step down transformers? You have to learn. Then you have to use this formula to solve the examples relating to the primary and secondary transformers. Fine. For extended student, you have to learn and understand the principal operation of simple iron core transformer. Then what's the use of 100% efficiency of a transformer. Then IP VP is equal to IS VS. Nextly, power is equal to I square R. Then nextly, fifth topic, that is nuclear physics. You have a nuclear model of atom, right? Atom you have to define. And for an extended student, they have a scattering of alpha particles, then nextly positively charged and negatively charged particles. Then nucleus, the relative charge of proton, neutron, electrons. We have to discuss what's a proton number, nucleon number, then how we can express the nucleoid, right? And then isotopes, the concept related to isotopes, what are the applications, fine. For an extended student, you have to learn and understand the process of nuclear fusion, nuclear fission, then nextly relation between the proton number, then charge on nucleus. These concepts are there. Then nextly radioactivity, second subtopic, then detection of radioactivity, then basic concept, the ionizing the nuclear radiation, count rate, nextly background radiation, what's a background radiation, concept relating to the background radiation. Then nextly 3 types of nuclear emissions, so alpha, beta, gamma, their relating concept, nature, then their ionizing effect, fine, penetrating abilities, we have to discuss here. For an extended student, you have to learn little bit more about alpha particle, beta, gamma radiations, fine, and their kinetic energy, electric energy, you have to understand. Then radioactive decay, so what's a radioactive decay, concept relating to it. For an extended student, you have to discuss isotopes, then alpha, beta, gamma radiations, fine, neutron is equal to proton plus electron, these concepts are there. Half-life is very important concept, so you will get definitely one question either for MCQ or written paper, fine. Half-life, isotopes, determine which isotopes is used for application including household fire, then irradiating food to kill the bacteria, then sterilization, measuring and controlling thickness of material, then diagnosis and treatment of cancer, these concepts are there. Then lastly here, the safety precautions. Okay, so for radiation we have to take number of safety precautions, and concept relating to the safety precautions are there for both core as well as extended student. For an extended student, little bit of extra safety precautions for all ionizing radiations and things like that are there. So then nextly, the last but not least topic, that is space physics. Again, this is one of the interesting topic because nowadays we hear Tesla launched this satellite and that satellite. So nextly, this country has launched that satellite, this satellite, and things like that. So we will be able to learn and understand Earth and solar system firstly here, okay, and the concept relating to the Earth orbit the sun, fine. So why it takes the 365 days, and the concept relating to the periodic nature of seasons, okay. So for an extended student, orbital speed v is equal to 2 pi over t, these concept is there, and the concept relating to the orbital speed, their problems, numerical examples are there. How moon orbit around the earth and moon cycle phases also we have to learn in the space physics, right, our solar system. Then nextly we have to discuss and understand sun, then planet, right, then Pluto, asteroids, okay, solar system bodies. Then for extended student, how they all rotate in the elliptical orbit and concept relating to it, such as orbital distance, orbital duration, density, surface temperature, uniform gravitational field strength at a planet surface we have to discuss. Then nextly, for a core as well as extended student, they have a concept relating to the solar models independent on the gravity, then presence of many elements in the interstellar cloud of gas and dust, rotation of material in the cloud. Then nextly, the strength of the gravitational field at the surface of planet depend upon the mass of a planet. Then the planet decreases as the distance from the planet increases, okay. So how strength actually affect, basically we have to discuss here. Then calculate the time, then know sun's solar system, why the planet orbit the sun, and the related concepts are there. Then nextly here, the strength of a sun's gravitational field decreases and orbital speed decreases as distance from the sun increases. These concepts are there, basic, fine. Then nextly, the second subtopic is star and universe. Sun is a star of a medium size consisting of mostly hydrogen and helium. Okay, what are the matters included in the sun? and sun's energy. Okay, we have to discuss in this topic. Then nextly, galaxy, then Milky Waves. These concepts are there. Then astronomical distance. So these are the concepts for the core student as well as extended student. Apart from this one, for a extended student, you have to discuss 1 light year. Okay, the star, they describe the light cycle of a star. Fine. Then nextly, protostar. Nextly, here all star eventually run out of hydrogen. How they run out of hydrogen, we have to discuss this concept, and this is theory part and even interesting when we discuss it, understand them. Then nextly, giant stars, red star. Then supergiant explodes as a supernova. Fine. Nebulous. Then supernova related concepts are there. Okay, so nextly, universe. Okay, the Milky Way is one of the many billion galaxies making up the universe. So we have to discuss the redshift as increases. Here for extended student, you have to understand the cosmic microwave background radiation, CMBR, concept relating to it. Okay, speed. Fine. Then nextly, Hubble constant. Then nextly, here some of the equations are here. Fine. And these equations we have to use to solve some of the problems as well in the space concept. So these are the concepts are there for your syllabus. Fine. And I hope you understood all this syllabus for core as well as extended student. Fine. So suppose if you want to connect with us, I have left the contact in the description box. That's it. We'll stop here. Bye bye.